Hi, today I'll be presenting our group project, AI project called Intelligent Waste Segregation System by our group O, consisting of five members, which is me, Muhammad Zaim bin Muhammad Azlan, Shafiq Azrin bin Zainora, Ahmad Fahim bin Sazali, Muhammad Hanif bin Ayub, dan Aimi bin Muhammad Nazim. So for the introduction, global waste generation is projected to reach 3.4 billion tons by 2050, and cycling contamination remains a critical issue due to public confusion about proper segregation. This project proposes an intelligent waste segregation system using Google's Teachable Machine, a web-based dashboard that classifies waste into recyclable and non-recyclable categories and provides actionable disposal alerts. Trained over 5,000 images per class, this system empowers users to sort waste correctly by the source, aligning by SDG 12, which is responsible consumption and production. Now let's look at the problem that we're trying to solve. First, let's look at the scale. So it's projected that 3.4 billion tons of waste will be produced by 2050, and this is sourced by World Bank. It's projected that every year the amount of waste will only increase, and the system will not be able to handle that amount of quick increase. The second is the hazard, contaminations and emissions. Improper disposal contaminates ecosystems and exacerbates climate change via landfill methane emissions. So land methane emissions will be produced by organic matter when it's crushed, and uh, methane is more potent than carbon dioxide, and it'll be a problem to our ecosystem. And then the last but not least is the bottleneck, manual sorting failure. For this matter, effective recycling depends entirely on segregation at the source. So people cannot just segregate or divide the trash at the landfill, because this will cost money, contamination to the workers over there, and it's less effective. So what we have here is called systematic failure. If the waste is mixed at the beginning, it's already too late. Okay, so now we'll go to solutions.
Let me introduce our solution. Our system is an AI power wasting clarification platform built using the Google Teachable Machine, which a mobile net V2 model. It was the web based, so it make it easy to access for any device which is browser. The system perform binary classification by identify whether the item is recyclable or non-recyclable. To prove accuracy, we train the model using over 5,000 images per class. User can either upload the image or using the webcam for real-time clarification, provide instant result. Next is a platform teachable machine. We chose a teachable machine because it allows anyone to create a machine learning model without writing code. It is a free browser-based platform developed by Google Creative Lab. The platform support image, audio, and post recognition for our project. We use image clarification where training data was collected by uploading image directly through browser. Since it's run entirely online, user do not need to install any software or create any account. So here our system works. First, the user upload the image and capture one using the webcam. The image is be proceed by resize it to 224 by 234 pixel, normalizing it and convert it into the format suitable for an AI model. Next, the pre-trained mobile net v2 extract the visual features such as age, texture, shape to clarify the image. The model generate the confidence score for both recyclable and non-recyclable class and check if the production meet our 70% confidence threshold. Finally, a role-based engine convert the prediction into the clear disposal recommendation display on dashboard.
Now I'm gonna talk about client server architecture. First, we're gonna look at the user interface or the front end. For the input, user will upload the file to the API in the data type of JPEG or the PNG, or use live webcam to capture the image via base64 or block. And then the image data array gonna be sent to the machine space or the back end. First, the engine, TensorFlow.js, loading and exported teachable machine model. First, the process first for the process, we're gonna perform the inference and within 2 to 3 seconds to ensure the seamless UX. And then the classification and confident alert gonna be sent back to the front end. For the output, we're gonna render the prediction and we'll have the confidence bar to make the output more visible and have visual alert. Now is data training, data and the training part. The total image we use for the training is more than 11,000 image total. The classes are recyclable and non-recyclable. The class per image is 5,644 image for each class. The image size is 224 by 224 pixel. The model architecture we use is MobileNet V2 to transfer the learning, and the training procedure is APOC 50 with batch size is 16 and learning rate is 0.001.
Now I'll be presenting the classification results when using image inputs. To test the system, we uploaded different types of waste images through the web dashboard. So as you can see, the AI was able to correctly identify each item and classify it into either recyclable or non-recyclable waste. So for example, the organic food and leftover food waste were both classified as 100% non-recyclable, while a glass bottle and a football were classified as 100% recyclable. So these results show that our model can accurately recognize different objects from uploaded images and provide the users with the correct waste category instantly. So this helps the users make better decisions when sorting their waste. And next, besides the image uploads, our system also supports real-time classification using a webcam. And in this test, users simply hold an item in front of the camera and the AI predicts the waste category immediately. For instance, crumpled paper and a reusable plastic bag were identified as 100% recyclable, while bread were classified as 100% non-recyclable according to our trained model. This demonstrates that the system is not limited to static images. It can also perform real-time waste classification, meaning it is more practical and convenient for our everyday use. So let's look at the overall performance of our model. The system achieved an overall accuracy of 100% with a training loss that was almost zero. In addition, the confusion matrix showed zero misclassifications, meaning every sample was classified correctly. The confidence scores ranged from 95% to 100%, indicating that the model was highly confident in its predictions. Overall, these results demonstrate that our intelligent waste segregation system is reliable, accurate, and effective for classifying waste into recyclable and non-recyclable categories.
All right, now we move to the next part, which is the discussion. First, we got the validation of approach. A teachable machine plus mobile net V2 is highly effective for binary waste classification. Second one is dataset quality. Over 5,000 images per class provided sufficient variety for the model to learn distinct features. The third one is transfer learning advantage. MobileNet V2 pre-trained weight give the model a strong starting point. It already knew how to detect age, shapes, and texture. All right, for the last part is the conclusion. All right, we got the summary of achievement. So, what we have done is we built an intelligent web-based dashboard using Google's Teachable Machine. We achieved 100 accuracy with zero misclassification.
It is user-friendly, dual input, and instant disposal alert. It also empowers users to sort waste correctly at the source. So what you're gonna do in the futures for the future work, we're gonna expand to identify plastic, glass, metal, paper, organic, e-waste individually. And then also test the system in on control environment, which is included the different lighting, angles, and backgrounds. That is to connect to smart bins for automated sorting and allow users to correct misclassification to continuously improve the model. So that's all for our group presentation. Thank you for your time.